Okay, so when we look at the parent functions here, we've got to know what the mom is in order to figure out what kind of function it is and what the effect was. So the mom was clearly an exponential function, which looks like this, and her equation is y equals e to the x. So we're going to base all of our translations off of the mom. So the mom is normally going through 0, 1, and now it has gone down from this point down 1, 2, 3, 4 units. So we know that it went down 4, okay? And doesn't look like it shifted to the left or to the right any, and it doesn't look like it expanded or condensed. So looks like that's the only transformation that occurred. So this is an exponential that went down 4, and now we have to have an equation that looks just like the mom. So it's going to have an e to the x power, and down 4 means, if you look at your transformations, that it affects the equation outside of the function instead of inside the function. And since it's outside the function, it's exactly what you think. So down 4 would mean that you're taking away 4. And notice that I'm taking away 4 from the entire function, not from the x value. So e to the x minus 4 would be your equation. This next one is definitely a polynomial odd. And so it's going to be, its mom is going to look like this, and its equation is going to be y equals x to the 3rd power because it's a polynomial odd. So here we'll write polynomial. Okay. And then the effect that it had, well, obviously it shifted, because this was the original that it went through. So it shifted to the right 2, and it shifted up 1. Okay, right 2 and up 1. No reflection, no compression, and no stretch. Excuse me. Okay, so we take the mom equation, which is y equals x to the 3rd, and we have to make the baby look exactly like the mom, but with these 2 transformations. So when you go to the right 2 on your transformation sheet, that means it affects the equation inside the function, which means I have to use parentheses, and it's going to be minus 2 because it's the opposite of what you expect. Inside parentheses is the opposite of what you would expect, and going to the right 2, you would have expected that to be a plus, but it's not, it's a minus. And then right and left affects inside the function, up and down affect outside the function. So now that this has gone up 1, it's exactly what you expect, and we're going to do a plus 1 outside of the function. Don't forget your little 3 up here, because that's what's going to tell us that it was a polynomial odd. So it's got to have that little 3rd right there. Okay, the next 2, we've given you the type of function that it is. You have to, and the transformation, you have to sketch it and give the equation. So polynomial even means that the mom looked like this, and the equation was y equals x squared. So we want that same one, but it's gone to the right 5, up 1, and a stretch of 3. Now, this on here doesn't tell you what kind of stretch it is. So we're going to assume it's a horizontal stretch. If they do not tell you what kind of stretch, then we assume it's a horizontal. Which means if it's a horizontal stretch of 3, that means that it has moved here, and it has gotten wider. Okay? Don't worry about figuring out if that should be really wide, just a little bit wider. All you have to do is show us that it's wider than the mom. So now when we write the equation, the right 5 tells us that it's going to affect inside the function, and to the right means that you would think it should be plus, but it's actually going to be minus. So this is going to be x minus 5 quantity squared, that's inside the function. And then up 1 means that we have to add 1 at the end. And then a horizontal stretch of 3 means that we are going to put a 3 inside this function. This horizontal stretch would be inside the function. So this is going to become 3x minus 5. Number 4, rational inverse. So rational inverse is going to look like this, opposites. And its equation is going to be y equals 1 over x. So we want to take that same equation and we want to move down 4. So notice that the asymptotes that we don't see are at zeros. So we want to move those down 4. So this one is going to stay the same, but this one is going to move down to -4. So it's going to be here. So when we draw our picture is going to look just like the picture we see up there, except it's going to be below the x-axis and not above the x-axis. So notice all I did was take the asymptotes, and since it didn't go left or right, then I kept the vertical asymptote the same. And because it shifted up or down, I moved the horizontal asymptote from 0, which it should have been right there, I moved it down 4 spots to -4. And so now the equation, because it was up or down, it doesn't affect inside the function, it affects outside the function. So we're not going to do anything to the x, we're going to do something to the outside of the function, and since it went down, it's going to be -4. Okay, on the back, they want us to graph the function using the given domain and in the restrictions. So the first thing we have to do is find the range. So if I substitute in, remember these are x values, these are y values. I'm substituting in so that I can get something out. So when I put a -2 into this equation and I add 2 inside the radical, that becomes the square root of 0, which is just 0. So 0 is my first part of my range. And then when I put a 7 in there, I'm going to do 7 plus 2, which is the square root of 9, and my answer will be 3. So I'm going to get 3 out. Now, because there was a bracket by the -2, I'm going to put a bracket by the 0. Because there was a parentheses by the 7, I'm going to put a parentheses by the 3. Now, what I would do at this point is I would graph the function based on the transformation that has happened. This is a square root function, and your square root function is that one that starts at 0 and kind of just shoots out to the right. But what's happened is that's the mom. This is y equals radical x. We want y equals radical x plus 2. The plus 2 tells us that we're going left 2 units. So you are actually going to draw this going that direction, so to the left 2 units. But I don't want the entire graph. So at this point, I want to erase, because the part that I want is I want the part that goes in this domain and range. And notice that this is my -2x, and the y that goes with it is 0. And this is my 7x, and the y that goes with it is 7, 3. So I want this graph to go from -2, 0, right here, to +7, 4, 5, 6, 7, 3. So I want it to end right here. Okay, so I want it to start here and end here. Now, we got to be careful about what kind of circles we should use. The -2, 0 should be a closed circle because those were both brackets. The 7, 3 should be an open circle because that one is a parentheses. And so now when I graph my graph, instead of having an arrow saying that it's going on forever, it's going to stop right there at 7, 3. Because that's my domain and range that I want to graph it under, from here to here. So closed circle right here, open circle right here, and the graph should look like this because it's a square root function. All right, over here, we have 1/2 x plus 3. That's a line. So since this is a line, you need to graph the line. Everybody should know how to graph a line. We begin at 3. We go up 1 and to the right 2. And then up 1 and to the right 2. Or down 1 and to the left 2. Down 1 and to the left 2. Down 1 and to the left 2. So this would be a line, but we don't want it never ending with arrows at the end. We want it under this domain. So let's find the range that needs to go with it. If I put in a -4, I'm going to do 1/2 times -4 is -2 plus 3 is 1. And I'm going to use a bracket because there's a bracket there. And then if I put in a 6, I'm going to do 1/2 of 6, which is 3, plus 3, which is 6. And that will be a bracket as well. So I want 2 endpoints that are colored circles or shaded in. So I want to go from -4, 1 to 6, 6. So -4, 1, I want to go from here to 6, 6, which is going to be one more. Up 1 and to the right 2 to here. And they need to be closed circles at the ends. I do not want this extra little circle that I wrapped over there. So that would be your this would be your line. Okay?